So here we have the equipment set up for our gas discharge tube. So we're going to be looking at the emission spectra of various gases. So what we have here is our induction coil, which is designed to step up from 6 volts to a couple of thousand volts, which is required to create the discharge in the tube. So we're going to go through all the different elements. We'll look at the color of the tube. Now, unfortunately, because of the limitations of the camera, you won't be able to see the full spectrum as you would in person, but you'll get an idea of it. But we'll also view the spectrum through the spectroscope. So you'll be able to see what light or what components of the light that's coming off the discharge tube. So here we have the tube set up for hydrogen gas. So it's a bit hard to see, but it has more of a magenta hue in real life. Now we'll look at it through the spectroscope. And you can see the different components that make up that light. So there's a predominant red and a cyan and a deeper blue. Now those other light, that spectrum that we see in the middle is more due to stray light. So now we have the tube set up for helium. So here I observe a very pale orange color, and we'll have a look at it through the spectroscope again. And you can see that there is indeed quite a bright line, emission line, coming from the orange-yellow part of the spectrum, and a few blue bands, and 1 or 2 long bands. So the tube now we have set up is oxygen gas. So this is O2 as a gas. Now it's a very pale color. Let's have a look at it through the spectroscope. Looks like the spectrum might just be too faint, so I might ignore that. Okay. So we have the tube here for neon, so one of the second noble gas, and you'll note that it is very, very bright. So this is why neon signs are actually just tubes filled with neon gas. So if we look at this through our spectroscope, you'll see very bright bands over there at the red and yellow spectrum, and not much else, hence why we get the red color. So here we have the tube for argon. Now, it doesn't come up as vivid, but it's actually quite a bright purple in real life. Now this is because we actually have some bands in the close to the UV spectrum, so the camera sensor wouldn't be as sensitive to that. So if you look at this through our spectroscope, spectroscope's not picking this one up. Ah, there we go. Very faint. I think the webcam is going to be limited in what we've displayed. We'll try the other spectroscope. So again, it's quite faint. The webcam isn't as sensitive to the different bands, but there we go, there we see. Predominantly blue and a little bit of red, hence why we see that purple color. So we have our tube set up for krypton. So almost a peach color. Again, it's probably going to come up as white. So I'll try to observe this through the spectroscope. So very faint lines, but it actually is distributed mostly through the spectrum. You can see that green and orange flash when I angle that spectroscope correctly. Alright. This is the tube for xenon gas.
It's to make an eye, it's more of a pale purple color. It's again, will show up more of a white on camera. We'll try looking at it through our spectroscope. So this is the spectrum for xenon. In case we didn't get it for the last clip, you see the different bands. Alright. So this is the tube for mercury. Now when I turn this on, one of the things that you will see is it looks very similar to the fluorescent tube spectra, and this is due to the way that fluorescent tubes work is they use mercury gas vapor to create the light. Now you're not going to see much in terms of light because a fair amount of the light actually is in ultraviolet. Now I'll turn this back on to have a look at the spectrum. Now we see a couple of blue and green bands, but we don't see much red. The reason we don't see the red is because in fluorescent tubes we have a phosphor coating which emits light in that red band to create the illusion of white light. For reference, to compare our emission spectra to a continuous spectra, so this is due to blackbody radiation, we're not using discrete electron jumps to create the light. Instead we're using heat, so there'll be a continuous spectrum. So sunlight is an example of this, or what we call blackbody radiation, and if we look at the spectrum you see that it's a pretty continuous smooth spectra. Again, the camera only displays red, green and blue because of the way the cameras work to simulate our vision, but in real life again you'll see a continuous rainbow spectrum.